All right, this is a continuation of your redox single displacement lab. So here we have an equation. If we took solid tin and mixed it with hydrochloric acid, we need to be able to predict the products of this single displacement reaction. And so this tin is going to displace the hydrogen because it's more active. And I'm giving you the information that the tin forms a 2+ cation in this case. Right, so if tin is 2+, chlorine is in group 7, so it's kind of a -1, so we need 2 chlorine per every 10. So we're going to form SnCl2 as one of our products. And hydrogen is going to be the other product because it gets displaced. And we need to remember that hydrogen is diatomic, so we're going to have H2 formed. Then the next thing we have to do is balance the equation. Right, and so we're trying to balance our tin, our chlorine, and our hydrogen. So if we look at this, we have 1 tin over here, 2 chlorine, and 2 hydrogen. On this side, we have 1 tin, 1 hydrogen, and 1 chlorine. So this looks pretty straightforward. If we put a 2 here, then we still only have 1 tin, but now we have 2 chlorine and 2 hydrogen. So now we have a balanced chemical equation. Right, so that's our balanced equation. So what we haven't really talked about in the lab are what are called redox, which means it's an oxidation reduction reaction. So we have a transfer of electrons. One thing is transferring electrons to something else. So what we should do is put our states of matter in there. And then we should write this as an ionic equation. So tin is a solid, it doesn't break into ions, but if we have something that's aqueous, it's actually breaking into ions. So we have 2 H pluses that are aqueous, and we have 2 chloride ions that are also aqueous. Our products end up being this tin with a 2+ oxidation state, plus 2 Cl minuses, they're aqueous. And then we have H2 gas, which doesn't dissociate. So we're seeing something new here. On this side of our chemical equation, we have 2 chloride ions. On this side, we have 2. So those are what are called spectator ions. They're not taking part in the chemical reaction. They're just floating along in the solution, balancing the positive and negative charges. So overall, what we want to do with a redox equation is look at the 2 chemical reactions. So what we have is we have tin here, and it's becoming tin with a 2+ charge, so it's becoming a tin cation. On the other half reaction, we have this hydrogen cations, and they're becoming H2 gas, right? So any element by itself has a 0 oxidation state. So tin is going from 0 to +2. But when we balance this, we need the same charge on both sides. So on this side, we have a 0 charge. Here we have a +2. So we add 2 -1 charges to balance the charge on our equation. Here we have +2 charge. Here we have a 0 charge. So we have to add 2 -1 charges to that side. And those are our 2 balanced half reactions. So tin is losing electrons. Remember, the loss of electrons is oxidation. Leo says Gur, and hydrogen is gaining electrons, so hydrogen is undergoing a reduction. That's our Gur, we're gaining electrons. So that's your balanced equation, and that's how it would split into the oxidation reduction reactions. So this is telling you that tin is more active than hydrogen because it's more able to give away its electrons and actually reduce hydrogen. So the second part of your lab, after you've built your activity series, is you should be able to take an activity series and predict if a reaction will happen. And a reaction will happen if we mix something higher up in the table with something lower. So these are the most reactive metals, and these are the least, right? Gold is one of the least reactive things. That's why it's good for jewelry. It doesn't react with the skin. Silver is also good for jewelry. It doesn't react with the skin, but if you start getting, jewelry made with some of these other metals in it, you might start having some reactions there. Right, so if we're trying to predict if we'll have a reaction in this equation, what we would want to do is see if this gold is actually more active than the silver. Is this gold going to transfer electrons to the silver? But gold is lower in the series, so we would expect no reaction. Right, and here we're looking at, right, so is this zinc going to want to give any of its electrons to this iron 3+? And what we want to do is see if zinc or iron is higher up, and zinc is higher than iron, so zinc will actually transfer electrons to the Fe3+, and so there would be a reaction. So the zinc would reduce the iron. Right. Here we want to know if the calcium is going to give off some electrons to the lead, so we see who's higher. Calcium is higher than lead, so we would expect a reaction here. Right. And same thing here, is this aluminum going to react with the tin? If aluminum is higher in activity, then it will donate electrons to the tin, and it will become a cation, and tin will become a metal that's not charged, so it'll become a neutral metal. Right, and so aluminum is higher up than tin, so we would expect a reaction here as well. So after you've collected your data, built your activity series, then the next part of the lab will be to use that activity series to predict whether reactions may or may not occur, and then to balance those reactions. So if we were trying to complete that final part here, if we're mixing zinc with iron nitrate, we said we'd expect a reaction. From our periodic table, we know that zinc always forms a +2 charge. From our polyatomic ions, we know that nitrate forms a -1 charge, so we need 2 to 1. So one of our products would be zinc nitrate, and then the iron would come out of solution. And then you'd have to balance your chemical equation, right? And so we have 3 nitrates here and 2 here. So we could put a 3 here, a 2 here, a 2 here, and a 3 here. And that should balance our equation at that point. Right? And so you'll go through that in the last part of your lab, use your activity series, predict whether those reactions will happen. If your activity series says no reaction, you'll write the word no reaction. If your activity series says there should be a reaction, you'll predict the products of those reactions. So remember, in a single displacement reaction, this metal is replacing this metal, and then you just balance the charges, and then you move forward from here. So if we're looking at this, we said there was a reaction. We know that aluminum forms a 3+, chlorine forms a -1. So we need 3 of these for every one of those. So one of our products is aluminum chloride, and the other is going to be tin by itself. Then we would go through and balance our equations. We have an odd number here and an even number of chlorine here. So we're probably going to need to put 2 there. That gives us 6 chlorine. Put a 3 here. That gives us 6 chlorine, 3 tin, and 2 aluminum. And then you have your balanced reaction that you predicted, your single displacement. This aluminum came over and replaced this. If we're going this way, too many arrows, our calcium is going to replace our lead. Our calcium is in group 2, remember, second group, so calcium is going to have a 2+ charge, oxygen is going to have a 2-. So those are going to go together 1 to 1, so one of the products would be calcium oxide, then the lead is going to be by itself, right? So the calcium displaced the lead. Here we have 2 oxygen, here we only have 1, so we're going to have to put a 2 there and a 2 there, and then we'd have a balanced equation. So that's what you would do with your actual data that we collected in the other video.